Okay, there is two more rules that we haven't really talked about in detail yet for exponents. And so the first one here is that when we are dividing, right, we know the rule. The rule says that if we are dividing the same base, we subtract the exponent. So 4 minus 4 is 0, so this would be 2 to the 0 power. And here, same thing. 5 to the 6, 5 to the 6. 6 minus 6 is 0, so it's 5 to the 0 power. And this would be a to the 0 power and x to the 0 power, because like the same thing minus itself is 0. But we don't actually write anything to the 0 power. What does that really mean? Well, up here, if I have 2 to the 4th power, that means I have 4 2's on top and 4 2's on the bottom. Remember, if anything divided by itself is 1, so I have 1 times 1 times 1 times 1, which equals 1. And the same thing would happen here. 5 divided by 5 is 1, and anything that pairs up with itself is 1. And 1 times 1 times 1 times 1 times 1 times 1, all of those still are just 1. So every single time that you have something to the 0 power, you are going to get 1. Okay? And if you don't believe me, get your calculator, type in any number. So here's 1, 2, 3 raised to the 0 power. And I get 1, right? Because it's saying that you have the same thing on top and the same thing on the bottom, and so there's nothing left, which is 1 by itself, because we're multiplying. So I have a few practice problems here. Negative 5 divided by a times b to the 0 power. Well, this whole thing right here is raised to the 0 power, which means it's just 1. And negative 5 divided by 1 is negative 5. Number 9 here says 12 times xyz to the 0 power. This whole thing is raised to the 0 power, so it's like saying 12 times 1, which is just 12. And then we're going to use our exponent rule of when we are multiplying, we add the exponents. So we still multiply the coefficients, so 4 times 2 is 8. Then I have x to the 5th. And x to the negative 5, so 5 plus negative 5 is 0, which means I have x to the 0, which goes away because it's just 1. And 8 times 1 is still 8, so it doesn't change anything. And then I have y to the 1 plus 3, which gives me 4. So now I have 8y to the 4th power. So anytime you have something to the 0 power, you just don't write it anymore. Okay, the rule that we really need to look at, though, is what happens when I have negative exponents. So again, if you are dividing, the rule says that you take the top minus the bottom. So I would say 5 minus 8, which means I get 2 to the negative 3rd power. Here I have 5 to the 3rd over 5 to the 6, so it would be 3 minus 6, which is negative 3, so 5 to the negative 3 power. And then again, I have 3 minus 8, which is negative 5, so a to the negative 5 power. And then I have 4 and 10, so 4 minus 10 is negative 6, so I have x to the negative 6 power. And I've been letting you write x to the negative 6 or any negative exponent that you have. And there's a slim chance you could see it that way because there was one test question like that. But really, we always like to change our exponents to positives. And the way we do that is we put it on the bottom of a fraction. So why on earth would we do that? Go back up to the top. If I have 5 2's on the top and 8 2's on the bottom, remember all the ones that match up become invisible ones. Or 1 times 1 times 1 times 1 times 1 is 1. But on the bottom, I have 1, 2, 3 2's. So I'm taking that negative exponent and I'm making it positive by putting it on the bottom of a fraction. So it goes into the denominator. Same thing here. The 5's that match up go away, and I'm left with a 1 on top and 3 5's on the bottom. So my negative turned into a positive. Here, my 1's match up, and I'm left with 5 a's on the bottom. So I have a 1 on top and a to the 5th on the bottom, so my negative became positive. And one more. My x's that match up go away. I'm left with 1 on the top, but I have 6 x's left on the bottom. So again, my negative became positive. And so on your formula chart, you also will see this rule, the negative power property, that says if you have something raised to a negative power, you put it in the denominator and it turns positive. So we're going to practice just writing these with positive exponents. So again, this is all negative, so I put 1 over 2 cubed. And now it becomes a positive exponent. But we also know that 2 cubed, if I type that into the calculator, 2 to the 3rd power is 8. Okay, so it's really 1 over 8. If you had typed in 2 raised to the negative 3rd power, you would also get 1 over 8. And that's why it's moving it to the bottom of the fraction. All right, number 12. We are dividing, which means I subtract the exponents. Negative 2 minus 3. Which gives me negative 5. So now I have x to the negative 5th power. And then my second step is to make it positive. So that just means put it on the bottom of a fraction. And now I have a positive exponent. Okay, number 13. We still have to do the first rule, which is to multiply. So I multiply my coefficients and I get 10. I add my exponents of my a's. I have 2 plus 1 is 3. And then I have my b's. Negative 3 plus 1 is negative 2. So that's the answer we've been writing. That's what I want you still to do first. And then I want you to come over here and make a fraction bar. And anything that has a positive exponent stays on the top. So 10a to the 3rd power. Anything with a negative exponent goes to the bottom, b, and it becomes positive, so b squared. All right, number 14. I have negative 15 divided by 5, which is negative 3. And then I have my x's, negative 2 minus 7, which gives me negative 9. So I have x to the negative 9. And then I have y. Y is 8 minus negative 2. Two negatives become a positive, so that gives me 10. So y to the 10th power. And then I have 1 minus 1. And 1 minus 1 is 0, which means I don't write it anymore. So now I'm going to make a fraction bar because I have a negative exponent. And anything with a positive exponent, so this negative 3 has a positive exponent, it stays on top. The y to the 10th has a positive exponent, it stays on top. And then we make this one positive by moving it to the bottom.